Okay, good morning or good whatever time of day it is, calculus students. I wanted to show you a little bit about a technique, a tool for your tool basket called U-Substitution. And U-Substitution is a tool that helps you evaluate integrals. And so I'm going to show you how they work. In the first example is sine of x cubed times 3x squared. And you might look at this and say, there is no closed form antiderivative for this function. But if you said that, you would be wrong. But if you're looking at it, you can't just, maybe some people can, or maybe after a little while, you'll be trained to look at that and see the antiderivative right away, like when Mozart looks at a piano or something. But I think early on, you look at that and it looks confusing. And so what we want to do is we want to make a substitution in here. And I want to make the substitution strategically. Well, I'm just going to show you what I'm going to do. I'm going to make u equal to x cubed. And then I'm going to make du equal to 3x squared dx. And what makes this a perfect u substitution is this du is substitutes in for a part of the thing that's in this function. So now in the next step, I can write this is the integral of the sine of u du, or like some say, do. And now what's the antiderivative of the sine? Well, I believe that's negative cosine u plus c. And then at the end of a problem like this, you have to go back and substitute in the thing that you put in for u. So this is negative cosine of x cubed plus c. Okay, so that's the basic idea behind it. What I'm looking for when I'm making a substitution, and this is something that I think you just have to practice. You're not going to be good at it until you practice these a couple times, and then you'll start seeing them better. But I'm looking to make a substitution for something that gets rid of a part of the problem. Okay, so you won't always, when we get into it, you won't always know by looking at a problem that it's a U substitution problem, or it could be an arc tangent or arc sine problem, or it could be U substitution. It could be a lot of different things. You just have to think of the different options that you have and find the right one. Right now, we're just doing U substitution, so I'm going to stick with that for a second. Sometimes the U substitution won't be, or sometimes there's a little bit more algebra involved in it. So example B is an example like that. So if you look at example B, you might think, what is the substitution that I want to make? And you might be like, well, last time I substituted x cubed. So in this case, I'm going to substitute x squared. But x squared wouldn't actually eliminate any of the other parts of the problem. And in this case, the x squared is on the outside of the function, where in the last case, the x cubed was on the inside of the sine function. What's inside the x squared function in this case is cosine of x. So I want to make that substitution. If I make u equal to cosine of x, I'm going to get du is equal to negative sine of x. So we're getting somewhere, but look at what we need. We need to substitute something in for negative 3 sine of x dx. Right now what I have is negative sine x dx. So, sorry, I said I want to substitute something in. I want to get this side of the equation to look exactly like this part right here. I think I may have said something wrong. But what I'm going to need to do is first get the negative there. So negative du is equal to sine of x dx. And then I'm going to multiply everything by 3. So negative 3 du is equal to 3 sine x dx. And now I can substitute in negative 3 du for that. And now it becomes the integral of u squared. I'm going to put the negative 3 outside of here because that's easier. So it's the integral of negative 3 u squared du. And this is going to be negative 3 u cubed over 3. The 3's cancel. So this becomes negative u cubed plus c. And we can't leave it in terms of u. So this is going to be negative cosine cubed of x plus c. And that's basically how you do it. And they'll get trickier and you'll need to practice. But there's another potential mistake that you make. Most years I would let you make this before I corrected it, but this year we're constricted on time a little bit, so I'm just going to kind of show you it's different. There's something that a mistake that you're inclined to make when you start doing problems that have a definite integral. So in this case, this is the same problem as I had before. I'm going to make u equal to x cubed and du is equal to 3x squared, and now I get the integral of the sine of u du. And to evaluate it, you might be like, well, that's from 0 to pi, but it's not from 0 to pi, because remember, u is something different than what x was in the original equation. So you have two options. One of them would be to solve this as an indefinite integral, and this would be negative cosine of x cubed plus c. Is that what we got? Yes, and you wouldn't need the plus c because it's a definite integral. You're going to be evaluating this from, now that we've put it back into terms of x, from 0 to pi. Or your other option would be, at this point, sine of u du. You can transform the boundaries. So we made this substitution that u is equal to x cubed. So this one down here could be 0 cubed. I could transform that into this ugly looking integral sign, 0 cubed. And this one I could transform into pi cubed. And then you could evaluate it from there. And you should get the same answer.